Morning fourth graders, we're at lesson 15 and we're going to be looking at some special objects in geometry called quadrilaterals. So our target is to define quadrilaterals and know the differences based on their attributes or characteristics. So before we begin this lesson, I want to cover some review and maybe some introduction to ideas of the attributes. Here I've will go on ahead and prepared for you some definitions and things for you to study, maybe make some flashcards off of, and maybe use some of the apps that I suggested to you earlier in the year, which would be quizlet.com on quadrilaterals or particular geometries. So first we have the quadrilateral as a whole, and I want to point out we're looking at the attributes of a quadrilateral. First of all, we know that quadrilateral, the word quad, this particular root word quad, it does mean four sides. So all quadrilaterals must have four sides. Because they have four sides, these four sides have four vertices. And so here we can see one vertex here, 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 and here. So four vertices because we have four sides and they form the associated vertices. So four vertices. We can think of each one as a vertex or a corner. The next definition that must be part of it is the sum of four interior angles equals to 360 degrees. So that means if you add up angles CAB, ABC, BDC, and DCA of this quadrilateral, then they all must equal to 360 degrees. So the sum, when you add them all up, we're going to have 360 degrees. No matter what quadrilateral we're talking about, it will always come out to be 360 degrees as a total. Now I've drawn for you a trapezoid diagram right here and labeled the vertex points A, B, C, D. And that's because I want you to see that the angles on the trapezoid are much different than the top picture or diagram. And what do you notice that the differences are? If you want to think of a Venn diagram, we could possibly list out those things. Well, firstly, you recognize that the quadrilateral up here is having perpendicularity. So all these sides are perpendicular to each other. And therefore, we could write them like such. So all those sides are perpendicular. However, on the trapezoid, there are no perpendicular angles on the vertex points. So none of these are perpendicular. They all have different angles, and that's because the lengths of a trapezoid sides are all different. So if it's a flat shape, has four straight sides, and those different sides are different lengths. And one required characteristic of a trapezoid is at least two of the sides need to be parallel. So how do we prove that? Do you remember when we had our protractor or our straight edge, we were able to draw a line? And if we drew a line through those 2 points and we dissected those lines AB and DC, then we could write that AB is parallel to DC, okay? And we know that to be true because with our protractor we can prove that they are 90-degree angles, therefore that is a trapezoid, okay? Some special types of quadrilateral characteristics are the square. So you can see here I've drawn a square here, 4 equal sides, and that they're all perpendicular to each other. The next one would be a parallelogram, meaning that it has 4 straight sides, but the opposite sides of each other are all parallel. So you will notice the top and the bottom are parallel, and then these that are about 45-degree angles here, those are parallel to each other. Then we have a rhombus. Rhombus is something that you probably saw as a diamond when you were younger, a diamond shape. and it says it's a parallelogram because the sides here are parallel, so too these are parallel to each other. And the opposite equal acute angles or opposite equal obtuse angles exist. So there, you can see if we zoom in here, the angle here and here are opposite and equal. That means acute because they're less than 90. And then these two here and here are obtuse, but they're equal to each other. So opposite angles of a rhombus, whether they are acute or obtuse, they're going to be equal to their opposite. And then lastly, we have a trapezoid again. Just to review again, you can see clearly on this trapezoid that no angle on the interior of this are the same. And then there are two parallel sides, but then the other sides are not. And there are no sides that are the same length as each other. Okay, let's go ahead and move on to the lesson. All right, let's go ahead and take a look using those definitions that we talked about earlier and see what we can find out. We're going to construct figures with the given attributes. Okay, so the attributes being what we talked about of these special quadrilaterals. They're going to tell us the attribute, and then we're going to draw a shape to figure out what type of quadrilateral would come out as a result. So you can name it beforehand if you like, but call it out as you see it. Okay, so it says, number one, construct quadrilaterals with at least one set of parallel sides. So we can go ahead and take our straight edge or ruler, and then we can begin doing that. I'm going to do it in yellow at first so you can see, looking for something that's parallel. Those look parallel to me. So if that's the case, that could be one set of parallel sides. And then it says the other sides don't have to be parallel, but they could. So you can come up with various types of possibilities. You can have one that could be a rhombus. Okay, and again, you're trying to make sure they all connect. You could have one that's a square. Okay, you might have something that is, I'm using this yellow parallel line to show you that there are various types of quadrilaterals that qualify for this. You can have one that would be a trapezoid. Okay. And you notice that the rhombus, this one right here, is also a parallelogram. If you note that the opposite sides are parallel to each other. Okay, so those all qualify for number one. Okay, so there's many possibilities for this answer. Number two, construct a quadrilateral with two sets of parallel sides. Okay, so we want two sets. Again, I'm going to use a different color to draw for parallelism, and I could decide to make it parallel this way. So we know that shape would be a square or possibly a rectangle. Okay, so maybe that's some type of rectangle or square. Let's take a look at if it came out as a parallelogram. Okay, that could be a parallelogram. Okay, so those are two possibilities. And again, qualifying could be a rhombus because if the sides are all the same length and they're parallel, it could be considered two sets as well. So there's many possibilities. The lengths might be different. They could be equal or different so long as we have two sets, right? Two sets of parallel sides. Okay, number three, construct a parallelogram with four right angles. Okay, I think more or less we know what parallel parallelogram with 4 right angles could be, it might be something like this one. Right, we can have a right angles shown right here. So we're proving that these are right angles. It could be also, if there are different lengths, then it could be, we know, not a square, but a rectangle. So those are also 4 right angles. So it's going to be either a rectangle or a special rectangle called a square. Okay. Then 4 says construct a rectangle with all sides the same length. Again, let's say that this is about as accurate as we get. If it has all sides the same length and it's a rectangle, then it's a special rectangle, and that's called a square. And we can see it's the same as that because it's a rectangle, which means it must have 4 right angles. All right. Number 5, use the word bank to name each shape being as specific as possible. All right, this is the fun part that you've done probably even in 2nd or 3rd grade, but now they're really asking you to understand some of these attributes that we've been talking about. So number 5A, we notice that there are 2 parallel sides, and then there are different lengths, but they're parallel, and then there are 2 sides that are not. So would that be a parallelogram, a trapezoid, a rectangle, or a square? Okay. Let's think about that. Well, is it a parallelogram? And the answer is there are not 2 sets of parallel sides. There's only 1 set of parallel sides. So the answer would be no, that's not it. Is it a trapezoid? Trapezoid meaning that there's 2 parallel sides and then 2 that are not. Sounds about right. So let's say that it's a trapezoid. Okay, next one, B, is clearly these little arrows point out that there's something going on here. They're parallel to each other. There's 2 of them on each of those, so that indicates that, hey, they're the same direction. And then these 2 have directions that are single arrows. So what they're trying to tell us with the symbols is they're parallel, 2 sets of parallel. So that would be a parallelogram. Okay. C, we can see that all sides are the same length because they have these little single hatch marks there. So those hatch marks mean that all sides are the same. Therefore, we know it's a special rectangle called a square. And then last but not least, process of elimination. It has to be a rectangle, but just to be sure, let's check the attributes. Rectangles say that there are 4 right angles in the interior, and therefore 4 times 90 proves to us that it's 360, so that's for sure a quadrilateral with a special attribute, which means that these sides on the rectangle are parallel to each other as well, right? But they're the same length, opposites. So that's a rectangle. 6, explain the attribute that makes a square a special rectangle. And we already saw this in number 4, and we're seeing that also here in 5C above it. What makes a square a special rectangle? And the answer? All sides are the same length. Okay. 7, explain the attribute that makes a rectangle a special parallelogram. Okay, rectangle is a parallelogram. Why? Well, we know from this diagram in 5 D right here, 5D, that it has opposite and equal parallel sides. So let's look at this closely. Let's use this diagram here to help prove it. We see that these two sides are parallel, and then these two sides are parallel. We also notice that they are the same length. Those two are the same length, and then these two are the same length. So because of that, it forms those 90-degree, four 90-degree vertex points. So that's what makes it special. And how do we word that? We could say the opposite equal length. So those are the sides. And then 4 right angles. And the most important part, 2 sets of parallel sides. Okay. Number 8, explain the attribute that makes a parallelogram a special trapezoid. Parallelogram is a trapezoid too? Okay, so we can go back to number 5 since they've done so well to draw them for us. And is a parallelogram a trapezoid? Okay, so let's just focus on those two on the top. So we're looking at the parallelogram, this right here. And what makes a parallelogram a trapezoid, but not a trapezoid, a parallelogram? You see, you can't reverse it. The first thing a parallelogram has is it has 2 sets of sides that have perpendicularity, and then in the case of the trapezoid, it only has 1 set of parallel lines. So we know that if I change the color here, let's go ahead and do that. If these two are counted like these two, then it qualifies as being a trapezoid. Nothing by the definition of a trapezoid says that the other 2 sides have to be the same length or parallel. But in the case of the parallelogram, they just happen to be also the same length and parallel to each other. So we're good to say that the parallelogram has all the attributes of a trapezoid and more. So it qualifies in the Venn diagram of things. It fits all the attributes. Okay? So this is going to be a little tricky. It says, explain the attribute that makes a parallelogram a special trapezoid. And it's special because it not only does it have a set, that means 2, of parallel sides, but also has a second set, I'm going to abbreviate, that are parallel and equal in length. Okay, so taking a look at all this, you really need to just understand the definitions. So going back to our definitions of quadrilaterals, and think about that Venn diagram that I keep referring to, is what are these different attributes that make quadrilaterals unique in themselves and also make them special. And the key thing is, how are they special? What makes them special usually is some kind of duplication of an attribute or some unique characteristic in that quadrilateral. Have fun.